So another aspect of a graph that we will be asked to find using derivatives is the relative extrema. And those are known as local max or local min. So there are some criteria for checking a relative extrema. It must have a critical point at x equals x naught. And remember, that means either f prime of x naught equals 0 or it's not differentiable there. And then once we check that, then we can use either the first derivative test or the second derivative test to show that there is a relative max or min. So honestly, these two tests both show the same thing, but we will practice both because sometimes they might ask you to specifically use the second derivative test in certain scenarios. So, or you only will have the second derivative. So it's important to be able to use both. So we want to keep in mind for the first one, it states that if f prime of x is greater than 0 on the left of x naught, and f prime of x is less than 0 on the right of x naught, then there is a relative max. So you have to think about that. It's greater than 0, so it's increasing, and then it's less than 0, so it's decreasing. So then there has to be a max there. The second idea is we have if it's less than 0 from the left and greater than 0 from the right, then there has to be a relative min, and we can visualize that, right? Less than 0 derivative means it's decreasing. Greater than 0 derivative means it's increasing, so that point there must be a min. And then overall, if it has the same sign on both sides, it does not have a relative max. So first derivative test for me is truly the easiest to find a min or max, but sometimes you might only have a second derivative, so we have to keep in mind how to approach that type of problem. So if f prime of x equals 0 and f double prime of x is greater than 0, then we have a max. Then we have a minimum. So let's think about what that means. If f double prime of x is greater than 0, then that means it's concave up. So therefore, this point here has to be a minimum. The next option is if f prime of x equals 0 and the second derivative is less than 0, then we have a relative maximum. So remember, if it's less than 0, that means it's concave down. So therefore, that critical value must be a max. And once again, there's always inclusive answers. If f prime of x equals 0 and the derivative is equal to 0, then it's inconclusive. We don't know what's happening there. So we are going to use both the first and the second derivative tests below to search for relative mins and maximums.